So, hello. Boom, buttons. My name is Maciej Fiałkowski, or if you prefer, you can spell it that way too. It works, sort of. You might know me from the PyPy project. Who have ever heard about PyPy? Okay, people know what it is, more or less. It's a Python interpreter that's fast, with just-in-time compiler. I also work at a company called ParadoxSoftware.com. And what we do is we do open source funding, specifically aimed towards PyPy. So it's a consulting arm of the PyPy project, where surprisingly most of the stuff that we do is not consulting. We just do open source software and people pay us to do it. Right now we are doing Python 3.5 for PyPy, and that's funded by Mozilla. Thank you, Mozilla. It's quite a lot of money because it's $200,000, and we got this through their open source grant. I have an entire talk on open source funding, so I'll just skip quickly through. But if you are interested in the topic, I gave a keynote last year at PyCon Asia Pacific, and it's online. It's on YouTube. Just to give you a quick example, CFFI is a project that's far more successful than what we ever wrote. It has over 1 million downloads every month, and it's unfundable. Unlike PyPy, which kind of manages to live off the consulting and the input that companies give us, CFFI is completely unfundable, and yet it's incredibly useful. So open source funding gives a perverse incentives that if you write your software too well, nobody wants to pay for it anymore. If you write it like sort of well, but not well enough, then people fund it. But this is not the topic of today's conversation. I kind of want to talk about the strengths and weaknesses of Python as a language and the Python ecosystem, especially speaking about culture. So for me, obviously, the topic is performance, since this is what I deal with, and how performance and the culture around Python affects the status that we have. I'll try to keep this talk to relatively limited technical details. And that's not because I don't know them. I know them very, very well. I just want to keep it to a wider audience. So if you have any technical questions, feel free to ask me. I'll be around the whole day today for the conference, and just ask me the technical questions. Otherwise, I'm reachable online, and we are usually happy to talk about technical stuff. It took me about, I don't know, 15 seconds from arriving to Moscow before somebody approached me and like, hey, I have this RPython question here, blah, blah, blah. Here we go. So technical questions are absolutely fine. Python is a good language. It's very easy to learn to newcomers, which is why it's widely taught at schools. And Python has a great ecosystem. I kind of want to emphasize that Python is merely a very good language, but the ecosystem is really great. It's something that does not exist anywhere else. JavaScript, while being a terrible language, is getting a very powerful ecosystem. So the ease of use and the integration into C is something that got us where we are now, where Python is widely available, widely known. It's one of the most popular languages. It mostly occupies the two niches. So one niche is web. It's hard to call web a niche these days, but okay. So specifically server-side software, where web is understood broadly by also microservices and stuff like that. That's where Python shines. Like there's a lot of Python software, very good libraries. It takes really very, very little to put up a minimum Python application. I think we run a competition on something, and if you know Python well, and you're given a set of libraries you've never seen in your life, it's feasible to put up a basic blog application within an hour, including reading the documentation and finding mistakes. This is incredible. Like, If we were trying to do this in mid-90s, it would take a team of 10, 3 months, and millions of funding. Now we can do it in an hour. So this is something very important. This is something that we got to deliver. And another big community and growing is scientific computing. So part of the reason why that scientific computing community is growing was because all the alternatives are terrible. How many people enjoy writing in Fortran 77? Like, this is not really a good language these days. Maybe it was nice in 77. Maybe it was already obsolete. But those are the two main areas where Python is great. It's my preferred choice, and not only mine, it's preferred choice of tons of people. Sadly, and this is something that we should ponder a bit, Python has no compelling story for client side. And like Kiwi guys would argue with me, but it's not prevalent by any standards. Like by client side, I mean specifically these days, what's client side? These days it's browser. These days it's apps on phones, so iOS, Android typically. And these days it's also gaming on the desktop. I don't think desktops are used all that much anymore other than for gaming and maybe a few applications here and there. So for example, I don't know, I would consider myself a competent programmer, and I absolutely cannot maintain a JavaScript program. Like, I start a project, it's always like, okay, I'm gonna test it, it's gonna be nice, it's gonna be structured, and then I'm with complete spaghetti and mess. I don't do web development all the time, but if you need to do an interface, it's gonna inevitably be web, because this is how you do interfaces. So I'm not a huge fan of JavaScript, and I get bitten all the time by like, I cannot write software in JavaScript that's not full of bugs. Like, undefined has no method 1, or like, has no attribute 1. Like, this is a typical problem. You sit there scratching like, why is that? The other client-side language that I used extensively recently is I've been developing a bunch of applications for VR, and that's in C#, because the choice is between C# and JavaScript. And I would absolutely love to use Python for that, but Python has no story. Like the fact that in Unity you can do things so quickly, and then you touch the button and you get builds for all kinds of platforms is something that in Python is really, really hard to do. So I'm going to talk a bit about, wow, that's a terrible URL formatting. I'm sorry about that. I wanted to actually put a graph, but then I looked at the resolution of this projector and I was like, okay, maybe you guys can look at the graph yourself. It's the graph of transitions from different languages. So, for example, it's also a good read, despite being a little heavy on math. For example, migrations to Python, the biggest things are either obsolete web technologies, so Perl and PHP, I mean, this is a biased conference, but I don't think anybody these days really wants to start a new project in PHP. If you're writing PHP, probably means you're working at Facebook or WordPress. No, seriously, like, it's really, that's why they struggle to find senior PHP developers, because you're either a PHP developer or you're a senior, typically. Like, you might have moved on the course of things because you found out that PHP is a terrible language. Like, we wrote a PHP interpreter once, and the sheer vastness of craziness is like, you do something that makes completely no sense. It gives you 2 notices and a warning and still manages to produce a result that also makes no sense due to type coercion and stuff like that. I could probably give a talk about like things you didn't know about PHP that would occupy an entire hour and would be a stand-up comedy. Another big transition is from R, Fortran, C++, things like that, into Python. And it's again, this is not a real competition. This is people who write Fortran at some point are like, okay, so I have this Fortran program that kind of adds numbers on a massive cluster, and I want to present stuff on the web. Who ever heard about the Fortran web framework? Ah, here we go. We know one. I haven't, for example. I would be keen to see how it looks like out of like software archaeology point of view. But yeah, like this is not too surprising that the numeric stack in Python is so strong that people will transition from Fortran or C++ or C often or R these days into Python. But what I want to avoid is this sentence. I mean, I spoke with many people at conferences who are like, yeah, we have this massive infrastructure, and it's in Python because Python is so easy to use, and that's how we started, and we got into like 100 users, 1,000 users, tens of thousands, hundreds of thousands of users, and then we had to migrate key microservices to Go because, or Java actually. Java is more common than Go when it comes to transitions. This is something I would like to avoid, and this is what this talk is about. Like, how do we avoid that? Where you start your project in Python because it's nice and easy, and then you get your project to the point where you have tons of users, and you kind of have to migrate out of it. PyPy is somewhat I know large companies, and I mostly can't talk on record about them. Mozilla is the one I can. Their auto-push service runs on PyPy. And this is somewhat of sometimes a stopgap, sometimes a full solution how you can do that. But sometimes you still need to rewrite it, except you rewrite it from Python to Python. And reasons are the rest of this talk. So this is the thing I want to actually talk about at this talk. So the question is Python in danger? Absolutely not. I don't think Python is going anywhere anytime soon. We have a massive set of libraries that's there to stay, but if we fail to acknowledge the dangers that we have and the problems that we have, that's going to be a problem. That's how we lose our major customers. So we have all those big companies like Dropbox, like Instagram, I'm sure tons of others, I just can't recall from the top of my head, but that use Python, and each time I talk to them, they say, yeah, we migrated, like, this is a C extension here, and this is Go there, and we communicate using some message passing queue. So you look deep inside and scary monsters, despite the fact that if a company is large enough, they probably run any software you can think of. So we need to acknowledge what are the problems and have a sort of plan how to go ahead. So one thing that occurred to me last week is that I am showing when I wrote the slides, am I not? Is that Python, I mean, if you consider PyPy as sort of fringe implementation, I think when I last ran statistics, it's something between 1.25% of all downloads are for PyPy of packages from PyPI. So that's not small, actually, because it's still millions and millions of packages, but it's also not huge. If we talk Python, a lot of people equate Python equals CPython. This is the predominant language implementation. And the runtime is terrible. Like, if you look into what others are suggesting these days, if you want to start a new project, what are your options? You're going to start it in JavaScript, Go, Python, or Java, maybe? And out of those, Python has the worst runtime. Like, if you ever consider performance, Python will come last. Maybe for bad reasons, but like, let's consider Java. Java programming language. Who have heard about Java? Most people, I would assume. JVM is really good. JVM is the cutting edge of technology, and I'm not just talking about a single JVM. Most JVMs that are out there, or all of them, are really solid pieces of engineering. And whatever you think about Oracle or IBM, they really don't try to save money on engineers who write Java virtual machines. JVM is really good. So, question to the audience, who thinks Java is fast? A few people, but not the majority. And why is that? Like, if JVM is so good, why is Java so slow? And then you sit on a train next to somebody who tries to start a web server in Java and takes 5 minutes. And you're like, what? What's going on there? Why is Java so slow? And the reason is that you can totally write code in Java that's fast, but culture and how you write software and what design patterns do you actually read matters a whole lot. So people wrote tons of horrible libraries in Java that are dog slow, and JVM just can't help it. Like, it's just too big, it's just too much. I don't know, I give up, I go home. So it's kind of important that the language shows you with efficient idioms how to do stuff. C is sort of a good example. I mean, maybe not for a lot of things, but C is very good at showing you how you're going to write inefficient code. Because it takes forever to do something that's inefficient. You would rather try to avoid than think about optimizing. Like, you're not going to sit and like, oh, I'm going to malloc this 500 strings. No, no, no. It's going to be so much trouble, like freeing them and thinking about it. Or you're not going to use Unicode. You're not going to use dictionaries, because dictionaries in C, regardless of what you use, are atrocious. So efficient idioms are important. Of course, a good language is the one that's easy to write in and easy to spot bugs and easy to read. A great language is the one where it's also kind of obvious what are the performance pitfalls when you write that. And runtime matters. What's universally accepted really matters. Like, the definition of Ruby is pretty much, Ruby is something that can run Rails. It's not maybe a very good definition, but it's a definition. So it's easy to come up with a new Ruby because if it can run Rails, it can be swapped for something else. And in Python, the definition is what CPython does, because you have to support all quirks of Python, and you have to support, additionally to that, the whole of CPython C API. So performance characteristics of CPython are prevalent across the libraries, because everybody is considering that as their first target for when things are fast and when things are slow. So runtime matters, and how easy the language is to describe matters a whole lot. Details are important. So I'll look into like the usual details of how people perceive why Python is slow. Dynamic dispatch is like the classic example. Value boxing. The fact that it's an interpreted language. The fact that it's dynamic. Garbage collected. So the funny thing, none of this is true. Those are solved problems. And when I was putting the slides, I was like, okay, those are solved problems for probably 2 decades since the first like optimizing Smalltalks came around. And then my colleague was like, no, they were solved for 2 decades when we started a decade ago. So those things are not really a performance issue unless you really need to deal to like lowest like single-digit percent for 30 years or so. So what actually matters? What makes Python a slow language? And if you write a program now and you write it in Go and you write it in Python, even if you run PyPy, chances are the Go will be faster. So for example, introspection. Introspection is good. I really like the fact that Python has introspection. It makes it easy to write debuggers. Like, if you ever interacted with GDB, especially in optimized C code, you know how hard it is because like value optimized the way, and you can't find the stack, and you can't find this. Introspection does matter, but it matters how exactly you do it. So in Python, it's just too easy. It's too easy to enumerate all the methods and like do something special about their names. It's just a single attribute access often to like read the class of stuff. The original Smalltalk or Strongtalk or that one, they introduce mirrors. So you do the same thing as in Java, where you have a special module in Python that would be the inspect module, and all the introspections have to happen through the module. So you immediately know you're doing something dodgy. And well, it's sometimes relevant, sometimes important to do, like if you write an IDE or you write a debugger or you even write a web server and you want to like dispatch based on the method name, but you've been spotted. Python also does unnecessary introspection for no good reason at all. Like, did you know you can do that? So you create a generator expression, and then you can fish the frame of the generator expression from somewhere, and then you can fish the locals, and then you can fish the actual list iterator being iterated, and then you can call next. So the next call to generator expression will generate a different value. This is nonsense. Like, this is completely unnecessary. We should kind of get rid of that. Well, also Python lacks, it's quite surprising, its lack of compile time. And you'll be like, wait a second. Like, it's good that you can run stuff. Yes, but then you have like this strange distinction between import time and the runtime that blends together. So if you had like a time when you say, okay, now we are building, now, like, that's why setup tools is such a pile of hacks. And for other reasons, I presume, but this is one of the reasons. If you had like the idea, like, okay, and now I'm building, then you could generate, I don't know, all the SQL queries for ORM. ORMs are like, they're written in a way that does dynamic dispatch all the time on runtime data, and I can't think of how you would write a VM that makes something like Django ORM run fast. So my recommendation, if somebody asks, well, how do you do fast SQL in Python, even if you're using PyPy, my answer is you use SQL, because SQL is nice and fast. But that's not a good answer. Like, this is not why we have all those libraries that help us to do things, so we don't use them when it's actually performance critical. No, that sounds wrong. So if you had compile time, we could build those things ahead of time, and we wouldn't need to do this at runtime, which comes back to the unnecessary introspection. So what do you pass? I have it written down because I really can't remember all the binary types that Python has. What do you pass to socket send? Unicode? No, you pass bytes, right? So what do you pass? Just bytes? What about something that implements buffer protocol? So the types here are buffer, byte array, memory view, array.array, CFFI buffer, or NumPy array. Those are all notions of binary types in Python. If you have that many notions of binary, you have no notion of binary, because if you had to do it 7 times, it means you never succeeded in doing this in the first place. Lack of notion of binary makes it very hard to do certain things efficiently, like read stuff from the socket and not copy it. Maybe it should be reserved for people who know what they're doing, but in Python it's really hard to do because you cannot arrive at the string. You arrive like somewhere halfway, copying stuff between different implementations of things that should be bytes. The kind of interesting thing that we discovered in PyPy is that the sheer vastness of Python language makes it really hard to optimize something, because there's so many possible interactions between components that it's impossible to predict. Like, do you want to use array.array? Okay, that's a separate module that's written in C and has its own crazy characteristics. Do you want to use itertools? That's again, like separate module. You would think that itertools would be written in pure Python because, well, if the language is good, then why don't you write in Python? Oh, because it's slow, then you write in C. Oh, and because we wrote in C, that has slightly different characteristics and implementation details that are actually undoable in Python without locks, for example. So you have to actually have another module that does this, or like functools is also written in C for no good reason at all. You'd think that decorators works just fine. And my favorite is the C API. So C API has about like, it grew in Python 3, but it has about 1,500 public functions, which is a lot. That's a lot of API to implement, even if it's simple. And if you write any other VM than CPython, it's not simple at all. You need to emulate the ref counting. You need to emulate all kinds of CPython internal details. And the CAPI is the primary reason why Larry Hastings struggles so much with the GIL-less Python, because, well, you need to do things that no longer make sense if you try to remove the GIL. So like, CAPI is quite bad for implementing other VMs. Other than PyPy, there hasn't been any reasonable VM that came along and said, okay, we're going to implement like full Python, full C API. Oh, there are a lot of people who said they would do it, but not actually somebody who did that, who implemented that and the fast JIT that would actually run very quickly. So one thing that like now CPython is trying to add interface for JIT, and that's hard because all of a sudden all your data structures are fixed because you created a C API that cannot be changed at all, or at least very easily. And numeric libraries, if I'm going to point fingers, they're the biggest offender here. They added hacks and hacks and hacks and hacks to work around Python performance problems, and most of this is keeping the C API alive. Like, we cannot just kill it easily. Another thing is concurrency models. Python doesn't have a sensible concurrency model. Even if we manage to kill the JIL, we're gonna struggle a lot finding the exact set of semantics that Python has. And additionally to that, threading in Python sucks. I mean, even if there was no JIL, I wouldn't like to use it because it's complicated and prone to errors, and Control-C doesn't work reliably, and blah, blah, blah. And frankly, the Python community is, when it comes to performance, is definitely guilty of years of promoting hacks. So my favorite quotes from people advertising how to do performant Python are like, at the end of the day, don't use Python. You go to a talk that talks about high performance Python, and the first thing they do is they introduce you to Cython, Numba, all kinds of things where you don't write Python. So maybe instead we should go ahead and fix Python so it's possible to write a fast VM in that. And then we have the culture that stems from the fact that programs are created with the ease of use of Python and with the ease of use of libraries, and then the performance never considered. And then even if you want to switch to PyPy, you are either stuck with like a bunch of C extensions. Most of them work these days, but they're not necessarily faster. Or you're stuck with a bunch of code that's slow and it's very hard to make fast. So the culture created a setup where Go is just faster because everybody knows that Go is a fast language. So when they write libraries, you cannot really push a popular Go library that's slow because people will complain. At least that's the perception. I don't even use Go. I don't know. Maybe that's not true. But the perception is there that in order to write Go, you need to write the Go that's fast. And we have like a bunch of libraries. Like, for example, there's a library called CapNPy, which is a Cap and Proto implementation that's really fast. It's fast on CPython, it's very fast on PyPy. It was written with performance in mind. So sure, this is a special case, but we can write Python libraries that are fast. Like, it's very feasible to rewrite Python to Python, run on PyPy, and get a service that runs 3 and 4 times faster. Not only because rewrites usually ends up with less features, but faster code. So I want to like summarize this with somewhat of like an outcome of what's the future. Like, first of all, there is no really language. I don't think there's a language to take Python's spot. I hope it's not JavaScript, because that would be terrible. I wouldn't be able to write software anymore. But what are options for us to improve the situation, to get to the point where we can start with Python, and then if we scale to the size of Facebook, we still can use Python. One option is we improve Python. That unfortunately means that we need to kill the C API, and the exact path to that is very hard. So I don't know exactly how to do, but we need to get rid of the C API, and we need to get rid of the mindset that Python is slow. We've done real-time processing in Python using PyPy that ran like 300 times faster, and the next step was really to write it in custom assembler. And yes, if you use the custom assembler and SSE and stuff like that, it is faster. But short of that, it's actually quite fast. Or we provide an alternative. And like by an alternative, I mean a language where main purpose would be to be fast, to be easy to use, to be good, but also be able to call into the vast trove of Python libraries. So be able to leverage the ecosystem that we created, and that's actually the biggest strength of Python. Or we can just do nothing. That's also a common approach to problems. And that wouldn't be a problem necessarily in the next 5 years. But it is, that way we lose our key big customers of Python, and there's always a pressure to migrate from Python to something more efficient. That's more or less it for the talk. The talk is already online. This is the URL if you want to review it. What are the questions?
No. Looks like there are no questions.
Cool.
Probably it was a very good talk. Thank you, Maciej.
I answered all the questions by the talking. Good.
Very nice.